We have been deploying more than 90 experiments in the last 4 years, evaluating crop models, satellite imagery-based recommendations, other tools like biologicals or inhibitors. So we're trying to produce, a good database to show the farmers what could be the benefits of using those technologies, and we're using that as well to fine-tune university recommendations from the extension point of view. Crossing all these basically programs, we're also focusing on developing what we call, and you mentioned in the introduction, digital dashboards. To make decisions, we need to develop things that are simple for farmers and extensionists and stakeholders. If they take a look to something and they don't get it in 1 or 2 minutes, if that will not add some value to their operations.
Welcome to the Crop Science Podcast Show, brought to you by Wyzenetics. I'm Brian Ernell, and I'm coming to you from the campus of Oklahoma State University. Today, happy to have on a colleague of mine, Dr. Guillermo Balboa. He is a research assistant professor in nutrient management and digital agriculture at the University of Nebraska, Lincoln. His focus is on developing and evaluating nitrogen management strategies on corn primarily, developing digital dashboards to help farmers improve their efficiency using precision agriculture, data analytics, and crop models to fine-tune Nebraska nitrogen management strategies. In the last 3 years, his research demonstrated that there is room to decrease nitrogen rates in corn with no yield penalty using PA technologies. And Guillermo, I'm excited to have you on today. And as you well know, everything you talk about is dear to my heart. And so excited to have the conversation.
Thank you, Brian. Thank you for the invite. I'm happy to join this to talk about a little bit about my research, how I'm arrived to Nebraska, and what are the cool things that we're trying to develop. Yeah.
So speaking of that, tell us your path. How did you end up in Lincoln?
Oh, well, that's a nice story. I think I will start saying that, as you know, I'm not originally from the U.S. I grew up in Argentina, in Cordoba. It's a central part of the country. An area that we grow a lot of corn and peanuts and soybeans as well. So I did my undergrad there in agronomy and pursued my master's in site-specific management, basically. And this will be touchy for you as well, because we were evaluating in my undergrad program the green seeker sensor with the colleagues in Argentina. With INTA. After my master's there, evaluating, again, site-specific models for corn and nitrogen rates in Cordoba. I came to the U.S. to Kansas State University to pursue my PhD with Dr. Ignacio Ciampiri, working in how we can close yield gaps with better, I would say, combination of crop management strategies. And I was doing that in corn and soybean rotations. Through all my career, I was very focused, and I will define myself as a cropping system with a high investment in all the digital ag tools, and particularly with nutrient management, because there are things that we can fine-tune to really impact those yields and try to reduce that space that we have between the maximum and what farmers are achieving. So that's kind of my passion. After that time in my during my doctorate, I moved to Australia, where I have a great time at CSIRO, the research agency from the government, developing the first digital farming established farm from the government there, and working how we can fine-tune, moving from corn and soybean to 8 different crops, and how we can put them into the right rotation to be more efficient per millimeter of water that we were receiving. After that, just before the pandemic, came back to Argentina to develop a precision ag program for the University of Rio Cuarto there, and then I joined in 2021 to University of Nebraska to the precision ag team where we are working right now. Yeah.
That's and you're based out of Lincoln, right?
I'm based out of Lincoln, in East Campus, Lincoln, Nebraska. Yeah, I'm leading basically the digital farming lab. That's the name of my lab. We move from precision ag, that is all the toys that you already know, to a broader concept that includes not only all the machinery or the data that can be generated with tied to a GPS point, but also IoT, Internet of Things, the use of crop models that you mentioned in the introduction. I do think that those tools can help us as a researchers and extensionists to develop new things that farmers can use to help them in the decision-making process. We don't want to tell them what to do. We just want to take advantage of all the things that we have around, to fine-tune those decisions. And at the end of the story, what they care, is to increase profits, production, but also take into account that we have a responsibility with the environment. Everything that we can do more efficient in terms of especially nutrient management will have a positive impact in the environment.
So, speaking of that, tell us a little bit about what your lab is doing. Tell us about what the active projects is going on in the Nebraska Digital Agriculture Project.
Well, that's a great question. I will try to focus maybe in two main things, as you say in the introduction. From the research point of view, we are trying to continue the evaluation of different techniques to develop better recommendation tools for nitrogen, mainly in corn. For that, we are, coupling all the great things that you can do with crop models, and also the great things and the benefits of using information coming from imagery that can be acquired with a drone or with a satellite. So we can couple those things and try to develop like a hybrid model that can help us to determine what is, I would say, the most optimal nitrogen rate, or what is the rate that will have less uncertainty when we apply into the field. We are not really focusing on a specific number, but a probability of a rate that we can apply that will be most likely the best rate to apply. So that's from the research point of view. From the extension point of view, all the tools that have been around in the market, I'm currently in the last year of in conservation innovation grant, where we are trying to test what is already out there with farmers, because I think there are a lot of research going, but that connection between how we take that into the field, I think is key. And for that, we have been evaluating with a project that was started for a little bit before I joined UNL. This is the last part of the project. We have been deploying more than 90 experiments in the last 4 years, evaluating crop models, satellite imagery based recommendations, other tools like biologicals or inhibitors. So we're trying to produce, a good database to show the farmers what could be the benefits of using those technologies, and we're using that as well to fine-tune university recommendations from the extension point of view. Across in all these basically programs, we're also focusing on developing what we call, and you mentioned in the introduction, digital dashboards. To make decisions, we need to develop things that are simple for farmers and extensionists and stakeholders. If they take a look to something and they don't get it in 1 or 2 minutes, if that will not add some value to their operations, it will most likely not work. So in that sense, we have two particular projects. One is a dashboard for nutrient management and water management. That's a national project that we're working with several universities, and it's already online. I can share later the link with you. But basically, we are using a more accurate forecast for the Corn Belt region, and we are using that forecast as an input to different tools in that model that can help us to predict, for example, corn growth stages with more accuracy throughout the season. That can help farmers to have a better sense of when things will happen throughout the season, especially with this variable weather that we're talking today. This tool has a forecast, 3 to 6 month forecast that is, since it's tailored for the Corn Belt, is more accurate. So it's based on NOAA predictions, but since University of Maryland narrow down the predictions to the Corn Belt, they are kind of more accurate. And from UNL, we're focusing on developing this tool using that forecast. And the other tool is, it's just a simple dashboard to benchmark how efficient farmers are being in terms of nitrogen use. Because we talk about a lot of this, about a new methods, but when we are going to these meetings and say, what is your efficiency? How are you doing in comparison to your neighbors? So we develop this digital dashboard where farmers just input, how much the corn they produce, how much nitrogen they input. As you know, irrigation is a big deal here in Nebraska. More than 70% of our cornfields are under irrigation. So basically, they will produce 6 different metrics for efficiency, and they can compare that with the farmers that are around there, operations that share the same soil and the same weather characteristics. They can compare with the farmers that are within the same NRD, and they can compare with farmers that are in the same county. So in that sense, they will have a red, green, and yellow, right? So if they are in green, means that, well, they are pretty as efficient as the top 33% people in their area. There's still always room to improve, but they are kind of sensing that things are going well. If you're in yellow, right, you are kind of in the middle portion in your area, and the second portion of this dashboard is to give you some recommendations based on the university experience. And if you're in red, means that, well, your numbers for productivity and efficiency are kind of in the lower portion for your area, and we can show them ways or avenues to improve that. So it's a very simplistic approach, but I think it could have a huge impact in farmers. Yeah.
Is that efficiency dashboard, is that on a farm scale or field scale?
It's on a field scale, so basically farmers, they need to introduce a legal description for the field, and they will see their fields in a kind of in a I would say Google Earth type of screen or format. Of course, all the data is fully secure. That we are not sharing among farmers. They will see only aggregated data. So you will select your farm, and you can see how your farm compares to the different farms. It will tell you how many farms are you comparing. So we are going to rely on farmers inputting the data, but also we are partnering with NRDs to access all the reports that they get from the farmers, so we can digitalize those, and we can have a huge database to compare. And I think that's very important because we always want to improve, but if we don't know where we are, right? So that benchmarking portion of that dashboard, I think, is very interesting. So we're in the testing phase now. And we are looking to get those larger databases, updated ones. Looking to do some launch in the next couple of months.
That's really interesting. I could see wanting to apply that in Oklahoma as soon as you guys, really go live with that, because that would be. It's a topic I discuss on a regular basis, is benchmarking yourself as that. Curious on the same format, is it annual, or can you look at series of years? So can a farmer go back and look at the last 8 years of management across fields?
Yeah, that's a great question. Yeah, we have an option, or basically you have a landing page where you can see your historical. And we are targeting just 5 years, 6 years, because we just want to be more consistent. We know that you can go large in terms of year, but yeah, the idea will be to have a kind of a historical component, because there are a lot of things that are affecting these decisions. There is a temporal component to this dashboard where farmers in the landing page, they can take a look to the last 5 years of metrics, and they can see that for all the metrics with what is basically the average for the different areas or counties or similar fields, and then they can compare with their own metrics. So yeah, there is a special component, temporal component, because as you know, there are many things that will impact how they're making decisions year by year.
Well, I'm thinking even, you're heavily irrigated right now. If that system were coming to the dry land environment, the rain-fed environment, now you almost need more years to compile to get a good sense of efficiency because of the inefficiencies of a wet year or a dry year, back and forth. And so that compilation of years under the dryland system would be quite important. I want to go sideways, kind of back to one of your earlier points in your discussions, that it just triggers something that happens a lot. You're a researcher, you do research, you do extension. You listed a litany of things. You talk about crop models, sensors, imagery, biologicals, stabilizers. How do you lump those all together in what you're doing in a conversation? Because there's independency and there's also integration.
Well, that's a great question, and as I like always to approach this as I will call a tier approach or a baby step kind of things. If you are talking to a farmer or a stakeholder that you want to know about what are these technologies they could implement, I will say first we need to know a little bit about what they are doing right now. Because if they are just applying, we just ran a survey last year statewide to know, what is the status of digital ag adoption in Nebraska, and then we asked particularly with nitrogen management, and we found out that 80% of the farmers, they rely on soil lab recommendations for for what they are doing. And then the second, I will say, most answered question option was that they rely on the intuition, traditional rate, or own experience. And we really value that. Because they know their fields. They might not have the site-specific management within it, but they know there are areas that produce more or less. But when you ask them if they use any of these crop model tools, digital platforms, or algorithms for many crops, so we don't get more than 15 to 20% of the farmers saying that they know that, or they kind of use that, or they want to use that. So the adoption, I think, of all these practices remains low, besides all the effort and the investments that many land-grant universities like yours or ours are doing in this sense. So I will say, the first approach, if just relying on what you're traditionally doing, establishing a nitrogen ramp study, it will be one way to start saying, okay, how my rate, benchmark within that. And we have some basic things that we need to take in account. When you do these nitrogen ramps, it's hard to put those lower rates like 50, 70 pounds. Of course, zero will be ideal to have, just to make that shape, I would say, quadratic type of traditional response to nitrogen, and just to understand how we are doing in terms of that. The second thing will be to try to see if the timing, and I'm talking always particularly about corn. Hopefully, university is not recommending anymore for irrigated corn fall applications of nitrogens, and we are pushing on that in our new recommendation that went out in last December. So taking out to the timing to move everything pre-planned or in season will be ideal. And then, of course, if farmers are fine-tuning that and they feel comfortable with the rates, starting to explore, using any crop model or imagery-based method to take a look to the in-season. And the concept behind that is that, if we wait until B6, B8, B10, we already know how the season is coming. If we have a good setup of the planting, if we don't have any issue with weeds or any early frost or something that can, impact our system, and we can, if we put all the nitrogen before, we don't have any possibility of managing or gearing up that recommendation. So if we wait more time and we use any of these tools available, I think that we can fine tune and be more accurate and reduce the uncertainty of that decision. And then again, we can go with crop models. You can go with any sensor-based or digital things. And then you have another type of, I would say, products or things that are, all the inhibitors or the biologicals that I do think they have a niche in the production system, but you always need to take in account, the big picture and the big decisions that I can impact. Besides fine-tuning, I will say, decisions that can impact yield, of course, but maybe that impact is in a smaller scale.
This is one that's gotten me a little bit perplexed, is why, to me, there's a natural fit between the biologicals and sensors or other aspects, because the biologicals are somewhat varied in their delivery of what's getting. You don't put down, it's not like putting down anhydrous where you put down 100 pounds of product, you get 82 pounds of nitrogen. The biologicals are environmentally sensitive, and there's a lot of things. And so the amount is not guaranteed, which has always seemed to be a nice fit for a sensor or a model or something that could provide in season. Okay, you've applied product X. It has in this environment the ability to provide, or we're seeing the crop respond this way. So let's be reactive in that. But I've not seen a lot of combination of those technologies. Are you seeing any of that?
We are, one thing to mention is that in our Nebraska On-Farm Research Network, we are evaluating a lot of these technologies, and we are also focusing a lot on developing the right protocol to evaluate all these tools. One of the things that we are doing is combining, for example, you mentioned biologicals. When you do these, I will call precision agriculture on-farm research experiments, where you can place, the typical strips across the field where you are, going through different soil types, and you have different management. So one of the things that we are doing, addressing a little bit about your comment, is trying to analyze the response of these particular products within different management zones, and we are finding sometimes difference differences. In maybe in areas that are more productive, the productivity is high. There is some type of response, and then adding an inhibitor or a biological, we change the shape of that curve. So there is an impact, and I think that newer technologies, I will say, precision I have been around for many years. When you say newer, you might be impacted, but I will say it's still a process to test those in the field and to get farmers involved on how we can use those technologies to get more out of it. Instead of using those small plots, 8 rows by 20, 30 feet, using all the new data analytics that we can implement in on-farm research, I think can give us a lot more value to evaluating all these products that I mentioned. In this particular grant, we evaluated like 6 different technologies, and with more than 90 experiments. There are some of them that are more consistent, and some of them that are less consistent. But we always need to take into account what was the condition of the experiment, and let's say if we are evaluating something that a product that will be inhibit leaching. Okay, did we have any leaching condition during the season? Because if you're evaluating something and you don't have the conditions, well, you cannot say that there was no response. There's basically particularly no conditions for that product to express the potential.
One of the ultimate challenges of nitrogen research is that we're looking for efficiencies of different products or even the right sensor, and we might not have a great nitrogen response. So maybe the crop only needs 60 or 70 pounds, but all treatments are 100 pounds. And so all treatments are equivalent, even though mechanistically, they are stopping leaching. They just didn't have that much leaching or stopping volatilization, or we didn't volatilize enough to see a crop difference, which gets into the big challenge of this kind of research across scale is, I know personally challenging finding, now you're in Nebraska, so you always have good crops and good weather and good yields, but we sometimes challenge finding even a nitrogen response on a farmer field. We go to farmer fields and it's not guaranteed to get a nitrogen response.
Well, that's a great discussion, and we have been discussing a lot in the last, I would say, year on all of these things because, I'm heavily involved in the on-farm research and how we place those treatment. And I was showing the other day experiment where the lowest rate was 100 pounds and there was no response. And what we are seeing with technologies like fertigation technologies that we're evaluating in this area is that there is a huge room to reduce that nitrogen application with, as you mentioned, the no yield penalty. And, maybe back in the time, we're thinking that precision ag will bump yields. And in this case, you can keep your same yields, maybe have a small yield penalty, but if you're reducing that nitrogen in 40 pounds, like we are seeing consistently in some of the experiments, that's a huge impact in your economy, in the environment, because basically there are 40 pounds of nitrogen that they were not needing in that system. As you know, Nebraska has a huge underground water issue with nitrates. University is working hard addressing, how we can cooperate with better management practices to reduce in the long term.
Yeah, it is interesting to see how nitrogen 20 years ago was purely economical, and it was typically an economic decision to reduce risk. It was risk aversion technique. And now we have some more societal influences coming in. And so there's still not necessarily an economic value, but there is more societal pressures and societal concepts that are coming in. I guess one of my last questions, in the time that you've been in Nebraska, and even in the time in Kansas, have you seen, I often hear this talking about corn specifically, the inability to do in season due to a mechanical, I don't have the equipment, I don't have this. Has there been any shift in that, at least in Nebraska, for more farmers saying they have the capability or willingness to do in-season management?
That's when we ask in this survey that I mentioned before, what are the limitations or barriers to adoption of particularly these technologies? And technology cost, as you see, is whatever everyone would think is the main. It's number 6 in our survey. The main one is the lack of information about the real value of the technology. That's 75% of the farmers say that's our top one. There are too many things around. What is the real value? What if I use this in my farm? What is the likelihood of having reducing nitrogen or something? The second one was the lack of qualified labor. So we are developing a lot of technologies. We don't have enough people with the right qualifications to manage them. Lack of time was number three. They don't have time to implement this. If this is too complex, overwhelming number of technologies, too many things around, and there is no a huge variety of the same technology. Let's say fertigation. There are not too many companies. So then, you have a lot of things, but you cannot, and that doesn't set the environment for competing, and then trying to find other things. And, number of technology costs, as I mentioned, was number six. And then as farmers sometimes feel that there are not enough trainings for this. So we are working hard trying to develop new courses, new digital badges to train our next generation. We have a minor in digital ag and precision ag at the university, and we're trying to develop now with the extension educators some digital badges to address all these limitations.
Well, Dr. Balboa, I have at least 5 more questions and conversations that I want to attack with you. Amongst them is even the challenge of what we do. And we don't have time for this, but I'm going to say it anyways. The challenge of what you and I do in a world, especially recently, where venture capitalists came in and there was a whole suite. And so company names, company people, company products is a whirlwind right now in PA on what's there, what's not there, who wasn't there. Going back, I've been doing this for about 20 years. You've been really involved, at least as a grad level, for 15 years in that realm. And so half the things that we started with 15 years ago aren't there, or the people have moved, or the products changed names 5 times. And what was once is no longer because it's under another. Anyways, it's a whole nother day that we could talk about this, but I've got to wrap up.
It's time for our famous 3.
WiseNetics turns podcast airtime into brand authority. We don't sell ads, we elevate voices. Curious how far your voice can go to become a reference in the industry and attract more leads? Scan the QR code and discover how we can turn your expertise into unmatched brand authority. Let's transform expertise into influence, starting now.
This is a problem getting my friends on here, is that I just want to keep going. That this should be an hour and a half long podcast. But with that, Guillermo, we go to the 3 last questions. Where do you go when you have a question with work? What's a go-to work resource?
I would like to advocate for the importance of all the extension publications from different land-grants universities, and I think it's a great opportunity with your podcast to encourage farmers, stakeholders to go to any land-grant university extension portal. We are working hard. I think many universities to update all those recommendations. From basic corn guides to national recommendations. I think that's important resources. Thinking about recommendations to give to the public. I think, I don't want to mention papers and a lot of things that are historically the first point of contact from the research point. But I think it's important to encourage all the audience to go and review all those extension portals, the land-grant university related to agriculture. They have interesting material, a lot of tools, digital tools coming in many places. I think that's a huge opportunity there. Yeah.
What do you do in your free time, Guillermo?
Oh, that's a tough question. Anyone will say that we don't have too much free time when you're an assistant professor. But I found out, and my friends tell me every time, that if I'm not good, if I don't have a future in agronomy, I can open my own restaurant because I really like to cook and invite everyone home. Every other weekend or every weekend,
What's your best dish? What is your...
Well, I have a lot of heritage from Spain and Italy, so a lot of pasta things, but also some Argentinian barbecue things, especially with the summer coming. That's a real top, I would say top 2 or top 3.
So with that, where do folks go to find out more about the Nebraska Digital Agriculture Lab?
Well, they can just Google Guillermo Balboa Digital Farming Lab, and if the first 2 or 3 results will come our website, where you can find different links to different platforms that we have. We are trying to push our Nebraska digital group together. Not only myself, a lot of groups within the university are working on this. We are trying to make an effort. We have a Nebraska Digital Act website as well. If you Google that, you will find out. And we're trying to concentrate all the efforts and make it available to the public. Yeah.
Well, folks, that wraps up another episode of the Crop Science Podcast Show presented by Wisenetics. Thanks for joining us today with our guest, Dr. Guillermo Balboa, Research Assistant Professor in Nutrient Management and Digital Agriculture at the University of Nebraska-Lincoln. If you enjoyed this podcast and those in the past, make sure you subscribe to the channel so that you can receive notifications when a new podcast drops. Also, share this video with your friends and your peers if you've learned something new, if you enjoyed it. Get the word out about the Crop Science Podcast Show. Also, feel free to leave us a comment if you have any suggestions, questions, or have a guest that we really need to bring on. Dr. Balboa, thank you so much for your time today. As I mentioned, you're a longtime colleague, and so these conversations never quite go long enough.
Thank you, Brian. I really enjoyed the interview.